Download this code from codegive.com, link in the description below. OK, let's delve into the DEF CON 25 talk by Joe Rozner about mitigating cross-site request forgery, CSRF, attacks. I'll break down the concepts, Rozner's approach, and provide code examples to illustrate the techniques. Keep in mind this is based on understanding the talk. I do not have the original slides or code. Also, securing against CSRF is crucial for web application security. This tutorial should give you a solid foundation. What is CSRF, cross-site request forgery? CSRF is an attack that forces an end user to execute unwanted actions on a web application in which they are currently authenticated. In simpler terms, it tricks a user's browser into sending a forged request to a server. The server, unaware that the request is malicious, executes it as if the user legitimately initiated it. How CSRF works, the classic scenario. 1. User authentication *. A user logs into a website, example bank.example.com, and establishes a session. A session cookie is stored in their browser. 2. Malicious website *. The user visits a malicious website, attacker.example.com. 3. The attack *. The malicious website contains HTML that triggers a request to the legitimate website, bank.example.com. This request is designed to perform an action, example transfer money. This is often achieved using a form submit or image tag. 4. Automatic cookie inclusion *. The user's browser automatically includes the session cookie for bank.example.com when sending the request. 5. Server execution *. The server at bank.example.com receives the request, sees the valid session cookie, and executes the action. It assumes the user intended to make the transfer. Why is CSRF dangerous? CSRF can allow an attacker to * change a user's password, * make purchases, * transfer funds, * change email addresses, * post content on behalf of the user, * basically, perform any action the user can perform, without their knowledge or consent. Joe Rozner's DEF CON 25 talk, Focus and Potential Solutions. Based on the general topic of CSRF and common mitigation strategies, Joe Rozner's talk likely covered the common defenses against CSRF and potentially some novel or more robust approaches. Since I don't have the specific content of his talk, I will focus on reviewing the standard CSRF defenses. Discussing more advanced techniques or variations that he might have presented, educated guess based on the topic. Providing code examples illustrating common practices. Common CSRF defense mechanisms. 1. Synchronizer token pattern, STP/CSRF tokens *. Concept *. The server generates a unique, unpredictable token for each user session, or sometimes for each form. This token is embedded in the HTML form as a hidden field. When the form is submitted, the server validates that the submitted token matches the token stored in the user's session. How it works *. The attacker can't guess the CSRF token. They can't simply create a valid request because they don't know the token value. Code example, Python/Flask. Login.html *. Transfer.html Explanation *. Generate _CSRF token, creates a cryptographically secure random token. At app before _request, ensures a CSRF token exists in the session before each request, except login. The transfer, root renders the transfer.html template, passing the CSRF token to the template. Asterisk the transfer.html template includes the CSRF token as a hidden field in the form. Asterisk process_transfer retrieves the CSRF token from the form submission and validates it against the token stored in the session. If they don't match, it rejects the request. Asterisk the logout root removes the username and CSRF token from the session. Asterisk the CSRF token is regenerated after a successful login and after a successful transfer to reduce the attack window. Asterisk important considerations for STP asterisk. Asterisk uniqueness asterisk tokens must be unique and unpredictable. Use a cryptographically secure random number generator, CSPRNG. Asterisk session binding asterisk the token must be securely tied to the user's session on the server. Asterisk token regeneration asterisk consider regenerating the token after each successful sensitive action, example password change, transfer. This limits the attack window if a token is compromised. Asterisk double submit cookies asterisk a variation where the token is stored in both a cookie and a form field. The server compares the two values. This works because attacker-controlled JavaScript can set cookies for other domains, but cannot read them. 2 double submit cookie asterisk. Asterisk concept asterisk the server sets a random, unique value in a cookie. This same value is also placed in a hidden form field, or included in the request body for AJAX requests. Upon submission, the server compares the cookie value and the request value. Asterisk how it works asterisk an attacker cannot directly set cookies for the target domain from a different domain due to the same origin policy, SOP. Therefore, they can't forge a request with the correct cookie value and request value. Asterisk code example, Python/Flask. Asterisk login _double _submit.html asterisk. Asterisk transfer _double submit.html asterisk. Explanation asterisk. Asterisk after successful login, the server generates a CSRF token. Asterisk it sets this token as a cookie named CSRF_token, with hp only equals true for security. It's also stored in the session. The same site equals strict attribute further restricts cross-site cookie usage. Asterisk the same token is embedded in the transfer _double submit.html form. Asterisk in process transfer _double submit, the server retrieves the token from both the cookie and the form data. It verifies they match. Asterisk advantages asterisk can be simpler to implement than STP in some cases, especially with AJAX. Doesn't necessarily require server-side session storage, the cookie acts as the session. Asterisk disadvantages asterisk relies on the browser's same origin policy being correctly enforced. If the SOP is somehow bypassed, the attack is possible. Also, be very careful about cookie scope and attributes. 3 same-site cookie attribute asterisk. Asterisk concept asterisk a cookie attribute, same site, that instructs the browser when to send the cookie in cross-site requests. Asterisk values asterisk. Asterisk strict, the cookie is never sent in cross-site requests. This provides the strongest protection against CSRF but may break some legitimate cross-site functionality, example links from external sites. Asterisk lax, the cookie is sent in cross-site requests only if the request method is safe, get, head, options. This offers a good balance between security and usability. Asterisk none, the cookie is always sent in cross-site requests. This effectively disables same-site protection and requires the secure attribute, the cookie must only be transmitted over HTTPS. Asterisk how it works asterisk by setting same-site equals strict or same-site equals lax, you prevent the browser from automatically including session cookies in requests originating from other sites. Asterisk code example, illustrative, setting a cookie with same site in Python/Flask. Explanation asterisk. Asterisk RESP set underscore cookie, sets a cookie named session underscore ID with the value 12345. Asterisk same site equals strict, specifies that the cookie should never be sent in cross-site requests. Asterisk only equals true, prevents JavaScript from accessing the cookie, further enhancing security. Asterisk secure equals true, ensures the cookie is only transmitted over HTTPS. Crucial when using same site equals none. Asterisk important considerations for same site asterisk. Asterisk browser compatibility asterisk older browsers may not support the same site attribute. You should use it in conjunction with other CSRF defenses for broader compatibility. Asterisk HTTPS requirement asterisk same site equals none must be used with the secure attribute. Browsers will ignore same site equals none if the secure attribute is missing. Asterisk impact on functionality asterisk same site equals strict can break legitimate cross-site links. Carefully evaluate the impact on your application's functionality. For referrer/origin header validation asterisk. Asterisk concept asterisk examine the referrer or origin HTTP headers to determine the source of the request. These headers indicate the URL of the page that initiated the request. Asterisk how it works asterisk if the referrer or origin header doesn't match the expected origin of your application, you can reject the request. Asterisk code example, Python/Flask. Explanation asterisk. Asterisk allowed underscore origins, a list of valid origins for your application. Asterisk important asterisk include both HTTPS and HTTP versions if your application supports both. Asterisk the root handler retrieves the origin and referrer headers. Asterisk it checks if either header is present in the allowed underscore origins list. If neither header is in the list, the request is rejected. Asterisk limitations asterisk. Asterisk not always present asterisk the referrer header can be disabled by the user or browser settings. The origin header is not sent in all cases, example older browsers, some redirects. Asterisk spoofing asterisk while difficult, the referrer header can be spoofed in some limited circumstances. Asterisk less reliable asterisk should be used as a supplementary defense, not the primary one. 5. User interaction, double confirmation. Asterisk concept asterisk before performing a sensitive action, require the user to explicitly confirm their intent. Asterisk examples asterisk. Asterisk requiring the user to re-enter their password. Asterisk sending a confirmation email or SMS with a unique link. Asterisk displaying a confirmation dialog box. Asterisk how it works asterisk an attacker can't easily automate this interaction. Asterisk limitations asterisk can be intrusive and degrade the user experience. Best suited for the most sensitive operations. Possible topics covered in Joe Rozner's DEF CON 25 talk, hypothetical extensions. Given the focus of DEF CON and the constant evolution of security research, here are some possible advanced topics that Joe Rozner might have covered. 1. CSRF in API-driven applications, SPAs and mobile apps. Asterisk problem asterisk traditional form-based CSRF defenses, STP, double submit cookies, are not always suitable for single-page applications, SPAs, or mobile apps that communicate with APIs using JavaScript. Asterisk potential solutions asterisk. Asterisk custom request headers asterisk require a custom HTTP header, example XCSRF token, to be included in all API requests. The header value is typically stored in JavaScript and set on each request. The server validates the presence and correctness of the header. Asterisk stateless CSRF protection asterisk using techniques like HMAC, hash-based message authentication code, to create a cryptographic signature for each request. The server verifies the signature without needing to store state. Asterisk token exchange patterns asterisk implement a token exchange mechanism where the client obtains a short-lived token from the server and uses it in subsequent API requests. Code example, custom header in Python/Flask. JavaScript, example. 2 bypasses and advanced attack vectors asterisk. Asterisk content security policy, CSP, bypasses asterisk discuss how attackers might try to circumvent CSP rules to inject malicious scripts and bypass CSRF defenses. Asterisk clickjacking combined with CSRF asterisk exploiting clickjacking vulnerabilities to trick users into clicking on hidden elements that trigger CSRF requests. Asterisk DNS rebinding asterisk using DNS rebinding attacks to bypass same origin policy restrictions and launch CSRF attacks. 3 automated CSRF vulnerability detection asterisk. Asterisk tools and techniques asterisk presenting tools or methodologies for automatically identifying CSRF vulnerabilities in web applications, example using security scanners, fuzzing, or static code analysis. For mitigation in specific frameworks asterisk. Asterisk providing in-depth guidance on how to implement CSRF defenses in popular web frameworks, example React, Angular, Vue.js, Django, Spring. This would cover framework-specific features and best practices. 5 novel CSRF defense techniques asterisk. Asterisk exploring less common or experimental CSRF defense mechanisms that might offer stronger protection or be better suited for specific application architectures. This could include techniques based on cryptography, browser security features, or machine learning. Key takeaways and best practices asterisk. Asterisk defense in-depth asterisk use multiple CSRF defense mechanisms in combination. Don't rely on a single defense, as it might be vulnerable to bypasses. Asterisk proper implementation asterisk carefully implement CSRF defenses according to best practices. A flawed implementation can be just as bad as having no defense at all. Asterisk regular security audits asterisk conduct regular security audits and penetration tests to identify and fix CSRF vulnerabilities. Asterisk stay up to date asterisk keep up to date with the latest CSRF attack techniques and defense mechanisms. The security landscape is constantly evolving. Asterisk use of frameworks built-in protections asterisk if you are using a web framework, leverage its built-in CSRF protection mechanisms. These are often well tested and provide a good starting point. Asterisk understand the trade-offs asterisk be aware of the trade-offs between security, usability, and performance when choosing CSRF defense mechanisms. By combining a solid understanding of CSRF attacks with robust defense mechanisms and a commitment to ongoing security vigilance, you can significantly reduce the risk of CSRF attacks against your web applications. Remember to tailor your approach to the specific needs and architecture of your application. Always test your defenses thoroughly.